Good afternoon, everyone. So I'll be going through exercise 7C. This is regarding the 3D word problem. The first question I'll be going through is question 6. All right, so let's read the question together. So OABCD is a pyramid. So the diagram is a pyramid there. And then ABCD is a square base, right? So square base means the length are all the same, right? And then it lies on horizontal plane. So M is the point of intersection of the diagonals of the base, right? And O is vertically above M. So that means we can say that OM is the vertical height. Okay, OM is the vertical height of this pyramid. Okay, so first let's start. So given that OA is 32 cm, find the height of AM. So in order to find the height of AM, right, I want to consider the triangle ABC. Okay, this triangle ABC. So as you can see, okay, I mean the diagram is drawn in a slanted way, right? But we know that ABCD is a square. So that means angle ABC is going to be 90 degrees. So let's just draw, I'm just going to draw it out. So like that. So A, C, and B. So this is 20, and then it's 90 over here because it's a right angle in a square, right? And then this is 20. So AC is the diagonal, right? So we can use Pythagoras theorem to find out AC. And we also know that M is actually the midpoint of AC because M is an intersection of the diagonals of the base. That means it means that M is the midpoint of AC. M is also the midpoint of BD. Okay, and M is directly below O, right? O is the top vertex of the pyramid. So when the top vertex of the pyramid aligns itself to M, right, that means M is directly in the center of the square as well. Okay, so that's why M is the midpoint of AC. So in order to find out what is AM, I will have to find out AC and then divide by 2 to find AM. Okay, so let's find AC. So using Pythagoras theorem, so AC square equals to 20 square plus 20 square, right, which is 800. And then AC is equals to square root 800. Okay, so AM will be square root 800 divided by 2, right, which is 14.1421, round off 3SF, 14.1 cm. Okay, so this is part 1, AM. Okay, let's move on to part 2. So the height of the pyramid. So height of the pyramid means find OM. So we are considering triangle AOM. So considering triangle AOM, right? The triangle looks like this. All right, then OM is what we want to find. AM, we have it, right? 14.1421. And then AD is 32. How come 32? Because the question says, where is it? Yeah, OA is 32 cm here. Okay, so and this is 90 degrees, because OM is vertically upright, right? So how do we find OM? So same thing, Pythagoras theorem, right? So we can say OM square is equals to 32 square minus 14.1421 square, right? So OM square is equals to 1024 minus 200, and then OM is equals to 28.7054, round off 3SF, 28.7 cm. So 3SF. Okay, so let's move on to part 3. Okay, so for part 3, find angle OAM. So we're going to make use of the same triangle over here in part 2. So we want this angle, angle OAM. Right, so right angle triangle. So we can use Tuakaso. So we can say something like sine angle OAM equals to opposite over hypotenuse, right? So opposite is 28.7054 over hypotenuse, which is 32. Right, so angle OAM equals to sine inverse 28.7054 over 32, right? Which give us 63.77216, round off to 1 dp because it's an angle. So 63.8 degrees. So 1 dp. Okay, so this is it for question 6. Okay, let's go through question 7 together. So ABPQ is a rectangular sloping surface of a desk, right? With ABCD, right, lying on a horizontal plane. Okay. Yep. And Q and P lie vertically above D and C. All right. Okay, so given that given that AB equals to PQ, AB equals to PQ, right? 90, 90. And then AQ equals to BP, 75, 75, because they're rectangle, right? And angle PBC is 25 degrees, same as QAD. So find AC. So for to find AC, right? To find AC, this diagonal, we need to make sure that we have BC. Okay, so the idea is we have to find BC, right? And then we use BC to BC with 90, right? To find AC, the diagonal of the rectangle. Okay, so in order to find out BC, we need to consider triangle BPC, this triangle over here. All right, so how to find out BC? Okay, so we will have cosine. So cosine 25 degrees equals to adjacent, which is BC, right? Over hypotenuse, which is 75. So BC is actually equals to 75 cosine 25 degrees, right? And this will give us 67.973. Okay, so that's for BC. Then now we need to consider triangle. Okay, so we have to consider triangle ABC, right? So we want to find AC, right? So AC square, right, equals to 90 square. Okay, maybe I write out lah. So AC square equals to AB square plus BC square, right, which is equals to 90 square, right, plus 67.973 square, right, and AC square, okay, we can straight away find out AC lah. So AC is just 112.7844, round off 113 cm, and this is 3 SF. Okay, so this is part one, right? Part one to find AC. All right, so part two, find angle PAC. So PAC is here, as you can see, PAC is here, PAC, right? Okay, so we have already found, and this is a PC is a vertical, what you call that? A vertical length, a vertical height, in relation, relatively to AC. Okay, so that means we can say that this is a right angle triangle. This is a right angle triangle. I mean, this is a right angle, so the whole thing is a right angle triangle. Right. So to find angle PAC, we definitely, okay, because we found AC already. Okay, we need to find this angle, right? So we need the height. Okay, we need the height. So for the height, right, we have to consider triangle BPC again, this one. Okay, so to find the height, right, we can use the same thing, 75 and 25 degrees, but this time round is going to be sine. Okay, so for part two, so for part two, sine 25 degrees is equals to opposite, which is PC, over by hypotenuse, which is 75. So PC is equals to 75 sine 25 degrees, which will give us 31.696. So that is the height of PC. All right. So now we have AC, we have PC. How do we find angle PAC? Right. So we have to use Tuakaso again. So opposite over adjacent. So tangent angle PAC equals to PC opposite over adjacent AC. Okay, so angle PA, which is, okay, let me write. So PC is 31.696 over AC, which we found in part one, is 112.7844. Please be sure to use the 5SF figure. All right, you cannot use like 113. If not, you might have a rounding off error. So how to find out angle PAC is just tangent inverse this fraction, right? 31.696 over 112.7844. And this will give me 15.697, round off to 15.7 degrees, 1 dp. Okay, so this is for part 2. Okay, now moving on to part 3. So find angle CAB. CAB is the one at the bottom. the one lying down. So that means you got to consider, okay, triangle CAB. So let me draw it out, right? CAB like that. Okay, so AC, all right, CAB is 90, right? So we have already found AC, right? This is 112.7844. And then we have also found out the BC, right? BC in part 1, 67.973. Yeah. Okay, so how to find out CAB? So same thing, right angle triangle, use Tuakasel. So opposite over hypotenuse, right? Opposite, I mean, if you want to do 90 here, it's fine also lah. Then you have opposite over adjacent. So okay, let's say we use these two values. So tangent CAB, angle CAB equals to opposite, which is 67.973, opposite, right, over adjacent, which is 90. So angle CAB, okay, anyway, I think it's better to use 90 because 90 is given, right? So we might not know whether if you have found AC wrongly or correctly, right? So better to use the figures that they give lah. So in this case, maybe it's a better choice to use tangent instead of using sine, because sine, right, you are making use of BC and AC, which are the two things that you have to find, right? And it's not given. So there's a chance that you might get it wrong. So angle CAB equals to tangent inverse, right? This fraction, and then you will have 37.0621 round off 37.1 degrees 1 dB. Okay, so this is for part 3, and this is for question 17. I mean question 7, sorry. Okay, let's do question 8 together. So the diagram shows a cuboid, okay, with a horizontal base EFGH, where HG is 15 cm, right? GF is 8 cm and BF is 7 cm. So all the things are labeled on the diagram already. So quite simple lah. Then go on. X is a point on AB, right? AB, and X is like, you know, on a point there, such that XB is 4 cm. So it's also labeled there. So find angle CEG. So where's angle CEG? So CEG is here. CEG. Wait. Okay, so that means we are going to draw a triangle like that. Okay, let me just draw lines lah, huh? So CEG, yeah. Okay, so CEG angle here, and then this is supposed to be 90 because this is a vertical height. Okay, and EG is on the horizontal plane. All right, so the first thing here first is we got to find our EG. All right, we need to find EG because CG is 7 ma, right? CG is 7, right? Because same as BF. Right, the height is 7. So we need to find EG. So how do we find EG? We consider this triangle HEG. So consider triangle HEG. Okay, so how do we find EG? We have EG square, all right, Pythagoras theorem, because this is supposed to be 90 also. It's a rectangular base. All right, so EG square equals to oh man, what happened? Okay, sorry. So HE square plus HG square, right? So equals to 8 square. HE is the same as GF, and HG is just 15. So 8 square plus 15 square, right? So EG is equals to square root 289. I just write in this first lah, because this is not my final answer anyway. Okay, so we found out that, you know, EG is square root 289. So how do we find angle CEG? So use Tuakasel. Opposite over adjacent. So we have tangent angle CEG, right, equals to opposite 7 over adjacent, which is 289. Okay, yeah, so angle CEG, just to recap, 7 is CG, then adjacent, this one is EG. Okay, so angle CEG is equals to tangent inverse this fraction that we have. So 7 over square root 289. Then we will get 22.380 round off 1 dp, so 22.4 degrees. 1 dp. This is an angle, so 1 dp. All right. Okay, so let's move on to part 2. So part 2, okay, they want us to find angles GXF. Okay, so let me erase the drawing that I have inside. So they want GXF. So G is here, XF. Okay, so definitely, right, this is also another right angle triangle over here, right? So we need to find out what is our XF first, because they want this they want GXF, this one, sorry. This angle over here, GXF. So we need to find out what is XF. So how to find out XF? We consider this triangle, XBF. So consider triangle XBF. Okay, so so how to find XF? So XF square equals to XB square plus BF square. All right, equals to 4 square plus 7 square. So I'm just going to write it in square root again. So XF equals to square root 65. Okay, so now we have XF, right? We have GF, right, which is 8 also. So how do we find the angle here? So same thing, opposite over adjacent, we are using Picasso. So tangent angle GXF equals to opposite, which is GF, over adjacent, which is XF. XF, right, equals to GF is 8, XF is square root 65. So angle GXF is equals to tangent inverse 8 over square root 65, right, which this will give me 44.777. Then I round off 44.8 degrees, 1 dp. Okay, so this is it for question 8. Okay, let's take a look at question 10. It's going to be the last question for exercise 7C. Right, so this question, I purposely picked this because there's no diagram. So we can, practice drawing the visualization on our own. So in this question, I think that is supposed to have 3 diagrams. Okay, we are going to draw around 3 diagrams. Okay, so first thing first, point PQR are on level ground with Q due east of P. So Q, right, is due east of P. So we're going to draw P here first, P, right, P, and then due east of P, right? Q is due east of P. So that means Q is at the east side of P. Okay, so Q is here. Okay, so east, right? And then R is due south of P. So assuming this is north, north, right? So this is east. Then the south is, of course, at the bottom. So south here. So R is here. Okay, so this is the south. Then, of course, this is 90 degrees. How come? Because the east and the south, right? Southeast, the whole angle there is 90 degrees, right? So this one, naughty elephant spray water, right? So 90 degrees here, right? So P is like here. This is like P. Okay, then they say a vertical mass PT stands at P, right? So it stands so there's a vertical mass. So I'm just going to draw it in this way. So the visualization I have is this. So P is at the bottom, then T is the top of the mast, right? And then the angle of elevation of the top T from Q. So that means Q, okay, so PQ is going to be here. And then from Q, right? So this angle here is 3.5 degrees as per the question. Okay, and then of course, then we go on. Given that PQ is 1,000, so 1,000 meter, right? And then PR is 750 meter. So we can label here. So PQ is also 1,000 meter over here. Okay, yeah, so 2 diagrams, right? I don't know how to draw it a 3D way, so I draw it like that for the vertical mast. Okay, so for part 1, right? So the bearing of Q from R. So Q from R. So let me draw a line here, right? Q from R. So because R is also facing P, right? And that's north, right? So the bearing is here. So we are finding angle PRQ. Okay, so how to find angle PRQ? This is a right angle triangle, so we're gonna use Picasso. So opposite over adjacent. So tangent angle PRQ equals to opposite over adjacent, right? Opposite is PQ over PR, which is equals to 1,000 over 750, right? So angle PRQ equals to tangent inverse 1,000 over 750, which is equals to 53 0.1301. Okay, because since they're asking for bearings of Q from R, I'll write a statement lah, right? So I'll say bearing of Q from R is equal to 053.1 degrees. This is my bearings. Okay, so bearings, remember, you need to have a 3-digit in front. All right, let's move on to part 2. Okay, in blue. So part 2, find the height of the mast. So the mast is here lah, TP. This diagram over here is at TP. Right, so same thing, right angle triangle, use Picasso. So opposite over adjacent. Right, so tangent 3.5 degrees equals to opposite, which is TP, over adjacent, which is 1000. Right, so TP is equals to 1000 times tangent 3.5 degrees, which will give us 61.1626, round off 3SF, 61.2 meter, right? Meter, 3SF. Okay, so that is the height of the mast. Okay, last one, part 3. Let me choose okay, orange. So part 3 over here, right? So the angle of elevation of T from R. So, okay, now we are going to draw another triangle, right? It's about R lah. Okay, let me draw here. So same thing, the height, right? P is here and T is here. But this time around, we know the height, 61.1626. Okay, and then from R. So now we are looking at R now. Okay, so we are at R. They want the angle of elevation of T from R. So look, we are at R looking up towards T. So this is the angle of elevation that we are finding. All right, and we have given information, right? PR is 750 meter. So we just got to find this one. Right, so how do we find opposite? Same thing, vertical, TP is vertical, right? Vertical perpendicular to PR, right? So it's a right angle triangle, so Picasso. So tangent angle TRP equals to opposite over adjacent. So opposite over adjacent PR, which is equals to 61.1626 over 750, right? So angle TRP equals to tangent inverse 61.1626 over 750 equals, then we calculate, right? Then we have 4.6621, round off 4.7 degrees. Because this is angle, so we leave it as 1 dp. And then since they're asking for angle of elevation of T from R, right, I'm just going to write a statement, same. The angle of elevation of T from R is equals to 4.7 degrees and 1 dp. Okay, can? So this is it for question 10.